Alright, so this video is going to focus on multiplying and dividing scientific notation. So numbers in scientific notation. So a couple of things you need to know, first of all, are going to be this. So you need to know your basic exponential laws, which means if I have a to the n times a to the m, okay, so basically if I have things being multiplied, if I notice that two of them have the same base, what I can do is I can add their exponents together. Okay, so that's an important quality. So if I have a strand of multiplication, meaning that I have 4 times 3 squared times 5 squared times 3 to the 4th, all right? So what this property is just saying that if you have things connected via multiplication, all right, and not addition, that's an important piece. So if you have a bunch of things that are just connected by multiplication, what you can actually do is before you decide to plug these into the calculator separately, you could do a quick little mental math step, and you could just say, hey, I noticed that these two, all right, have the same base, all right? So what it means is I could just take those two, okay, and I could just add their exponents. So instead of doing 3 squared and 3 to the 4th separately, that would be the same thing as me just doing 3 to the 6th. So what I did there was the 2 plus the 4. So that's what this property is saying. It's just saying, hey, if you notice that, the key to it is it has to all be linked by multiplication, all right? So then likewise, what we have is we've got division. So we've got this thing called a to the m, okay, divided by a to the n is equivalent to a to the m minus n. Now, what's important about this one is that subtraction is has to be in a specific order. So the specific order you're going to do is always the top minus the bottom, and that's an important concept, okay? So this all is going to directly play into it. So again, what this has is, say, pretend I have some numbers like 5 times 4 to the 3rd divided by 6 times 4 to the 2nd power, right? So what this is just stating here is that literally, okay, before I do my division, so before I actually do 5 times 4 to the 3rd, all right, and then 6 times 4 squared, I can actually make my life a little simpler here by just saying, okay, I'm going to do 5 times 4 of 3 minus 2 divided by 6. So notice that I brought the bottom, went away, right, because I took this one and I'm subtracting it up here. All right, so the 4 doesn't come with it. We're just talking about the exponents. It's the same base. So now what I end up getting here is I get 5 times, well, 3 minus 2 is 1, so that's 4 divided by 6. So then I can do my multiplications and simplify from there. So those are the basic groundworking that you need to be able to do something that is in scientific notation. So scientific notation, all right, so I'll leave those up there. Scientific notation is important because scientific notation is just taking a number and writing it between 0 and 10. So you have to have like 3.2, and then they're going to say, hey, so they're going to write a little time symbol, and then they're going to put 10, and they're going to give you an exponent. So say I have 10 to the 5th, right? And then they're going to say to you, okay, well, what if they want you to multiply these two? All right, so let's say they take this, and they say, hey, multiply that by this other one, which is say like 4, okay, times, and we'll do 10, and we'll say to the 3rd, okay? And they want you to multiply it. So basically, they're giving you two numbers in scientific notation, and they're just saying, hey, multiply. So basically, you're going to come down here, and you're just going to put a multiplication symbol between them. So I throw a multiplication symbol, all right? And now what I'm going to do is I'm just going to utilize this property up here, okay? So the way I finish this off, all right, is I utilize this property. I'm just going to look up here and go, hey, do I have anything that is a number or a variable? It doesn't have to be a number. It could be a variable as well. Okay, do I have any number that is also being used but to a different exponent? And the answer is yes. So notice I have a strand of multiplication. So what I'm going to simply do here is I'm going to say, hey, before I do my multiplications, okay, I'm going to take these two and I'm going to utilize this property. So this is 3.2 times 4 times 10 to the 5 plus 3. So as opposed to doing 10 to the 5th and 10 to the 3rd separately, I'm just doing 10 to the 5th, which is plus 3, which is good old 10 to the 8th. All All right. Now, it saves you a little bit of time if you can do that quick mental math, right? So then we go here. So 3.2 times 4. So 3.2 times 4 is 12.8. And then you're multiplying that by 10 to the 8th. All right. Now, you would not leave it like this because remember that this number here needs to be between, all right, needs to be between 0 and 10. 12 is greater than 10. So what I need to do is I actually have to get this decimal to go that way, all right? So how do I get that decimal to move 1 to the left, right? So how do I get that number to go 1 to the left? And what I'm actually going to do here, all right, is I'm going to take this number, and what I'm going to do is I'm going to say, hey, I actually, okay, need to pretend that I have this number, okay, 1.2. Well, how did I move it that way? Well, I moved it by a power of 10. So this was to the 8th. So it was to the 8th here, all right, which means I would go that way 8. But now I'm going over here, which means to get to the same place that this dot moves 8, this dot needs to move 1 extra. So this final answer becomes 1.28 times 10 to the 9th power. And that's the final way of doing it, right? At this point, okay, you may also be on a quiz or a test that just gives you the number. So literally at this point, you could always just type that in your calculator if you wanted to. Or you should know, scientific notation, this number, all right, is telling you how many times to multiply this by 10. So you could have done 12.8 times 10 8 times and got an answer. So you would have gotten 12, 8, and then 7 zeros on here. Okay, if you type that in the calculator, this is the number you would get. You'd get 1,280,000,000. So that would be your final answer. So if you didn't want it in scientific notation anymore, if your teacher does want it in scientific notation, then you'd convert back to this, okay? So moving on. So that's how you multiply. So let's talk very quickly about how you divide. So division. So let's say I have 12, okay, times 10 to the 5th, all right? And then I have this other thing that is like 4 times 10 to the 2nd power, all right? And it wants you to divide these. So now I'm going to divide them, right? So division symbol goes between them. Now, this is not how you would write this problem. You would have to write this problem utilizing this property here. So all we're going to do is take this division symbol and turn it into a fraction. So I'm going to write it down here instead. So this is 4 times 10 squared. Okay? And now, much like I talked about over here, all this rule is stating is that if you have things that are being multiplied together in the numerator and denominator, what you can do to make your life a little simpler, okay, a little simpler, is to recognize that I could just take these and subtract them. All right? So I go over here and I go, okay, 12 and 4 are not the same. But hey, look, I got a 10 and a 10. So I look at their exponents, I go 5 and 2. Well, instead of typing these two numbers in separately, all right, to do a little mental math with this, all right, what you can do is you can turn this into 12 times 10, and you're going to now do this 5, all right, minus, okay, minus, because it's division, this number down here, which is a 2. So then you're going to leave your 4 in the bottom here, so still we're dividing by 4. So the final answer becomes 12 times 10 to the 3rd power divided by 4. All right. Now, this also can be changed into, transformed into that this is really just 12 over 4 times 10 to the 3rd power, which is an important concept because now you have 12 times 4, which is equivalent, or 12 divided by 4, which is 3, and then you have 3 times 10 to the 3rd. Now, a problem like this, they'd want you to probably give you the final answer. So the final answer to this one, okay, this 3 here tells you how many times you need to move a decimal, or how many times you need to multiply this by 10. So this is 3 times 10 times 10 times 10, right? Well, 10 times 10 times 10 is 1,000. So this is 3 times 1,000. So my final answer to this one is good old 3,000 if you're taking it out of scientific notation. If you're leaving it in scientific notation, that's my answer. But outside of scientific notation, there it is. So these are always kind of like the heavy hitters on state assessments for like non-calculators. By the time you get to like 8th grade, they like to give you these because they like to check your exponential laws of numbers for here. So I hope this helps with whatever you're doing. It's just a quick way of doing some scientific notation, multiplying and dividing. So I hope it was helpful running through those properties.